Alright, so on number one, or really not number one, but the first problem, I went ahead and wrote in the numbers that were kind of cut off there. But let's go ahead and start by looking at the first one that we need to label for angle A. Remember, this here, whatever's after the trig function, remember trig functions are sine, cosine, or tangent. So whatever's after the trig function is the angle that it's telling us to label the triangle for. So we're labeling it for angle A. And remember, the first thing you want to do is recognize where your hypotenuse is. So if you draw a line across from the right angle, that is our hypotenuse. So that's our HYP. And then if we draw a line across from the angle it wants us to find to the other side, that is the opposite side. So the opposite side is always the side across. And then the adjacent side is just the leftover side, basically. Adjacent means next to, so it's the one next to the angle beside the except the hypotenuse. So, or other than the hypotenuse is what I should say. Alright, so it wants us to find the sine. Now remember that whatever little saying you want to remember for the trig functions, that the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So if it wants the sine of angle A, then we have to do opposite over hypotenuse. So we already labeled it. So we just need to get the opposite length, which is 14, over the hypotenuse, which is 22. So we have 14 over 22, which simplifies because they both could be divided by 2. Now remember, you don't have to simplify by hand. You could just put 14 over 22 in your calculator, and it'll simplify it for you if you're using the TI-36X. But it'll simplify it to 7 over 11, and that is our simplified version of the sine of A. So now if you just look at the next problem, it says tangent of B. So we'd have to relabel the triangle for B. So it's kind of wise to kind of look ahead and see, okay, that one wants it for B, well this one wants it for A. So we might as well go ahead and do number 12 since it's already labeled for A. We already have the opposite and adjacent labeled for angle A. So tangent, if we look over here at our trig functions, tangent is opposite over adjacent. So we have on our triangle, we see that the opposite is 14 again, and adjacent is now 18, or not is now, but is 18. And then if we simplify that, that'll simplify to 7 over 9. So that is our simplified version for tangent of A. Alright, so now that we're going to do 10 and 11, we have to relabel the triangle for the angle B because it's assigning the instructions are telling us to use angle B instead of angle A, so now the sides are going to change. Remember that the only one that does not change is your hypotenuse because it's always across from the 90-degree angle. That's never going to change. So your hypotenuse is always going to be in the same place no matter which angle you're looking at. And that's why it's always good to find it first. But the problem is we're no longer looking at angle A, so the opposite side is going to now change. Well, I'm going to have to rewrite that 14. But the opposite side is going to change because we're looking for the side that is opposite of angle B. So remember, if you draw a little angle and draw a cross from that angle, that is our opposite side now. So now opposite is now the 18. And then we already have our hypotenuse labeled. Now we have the adjacent is our 14 side because it's really the only side left. And it's also next to the angle, but not the hypotenuse. Alright, so now we have it labeled correctly. And this is the same color as the writing, so I'm just underline. And let's go ahead and see what the tangent is. So it wants the tangent of B. Well, looking over here, tangent is opposite over adjacent. The side length that is opposite is 18. And then adjacent is our 14. So if we simplify that, it becomes 9 over 7. And now if we look at number 11, it's asking for the cosine of B. Well, the cosine of B, remember cosine is adjacent over hypotenuse. So adjacent is 14 and hypotenuse is 22. So we have 7 over 11. And there we have it, 7/11. So something to note that we've talked about before is that the sine of one angle, one acute angle, is going to, see how it's 7/11? It's going to equal the cosine of the other angle. See how that's also 7/11? So it's always the sine of one angle is equal to the cosine of the other angle. Those are going to be equal. If you notice something a little bit on 10 and 12, you'll notice that the answers, which I don't know, I didn't box that one, but the answers are just reciprocals. So the tangent of one angle is the reciprocal of the tangent of the other angle. Now, you don't have to necessarily know that, but it helps to know that when you're doing these, just to make sure you check it and understand it. And really, that first relationship I mentioned, that the sine of one angle is congruent to the cosine of the other angle. That is something you want to know because on number 13, it says, given some triangle ABC, the sine of the angle is equal to 15/13, and it's asking for the cosine of the other angle. Well, how do I know that means the other angle? Because if you think about it, you got a right triangle, you might as well draw it whenever they describe it. They're telling you the sine of theta. Now remember, you're only going to do sine, cosine, and tangent for angles that are acute angles. It's never going to be a right angle. So basically, I could put theta here, or I could put theta here. And remember, theta is just a symbol. It's a Greek symbol that's used for angle measures, for an unknown angle measure. So you can put either acute angle. But remember that an entire triangle adds up to 180 degrees, the angles inside. So if they all add up to 180 degrees, and right here we have a right angle. Remember, all right angles are 90 degrees. So right there, that angle alone is taking up 90 degrees out of that 180. So if you subtract, you're left with 90 degrees that these two angles have to share. So whatever theta is, no matter what it is, I can just subtract it from 90 and get what this one equals over here, because those together have to add up to 90. So that's what this is saying. Well, if we know theta is equal to this, well, the other angle, in words, I would just read this in my head as literally the other angle, or the other acute angle. That's all that means. And the cosine of the other angle. It wants us to find those. So we can label this triangle. I kind of made it messy, so I'm going to erase it and do it again. But we can label the triangle, and we can figure these things out pretty easily. But what I was saying is the relationship we know, well, the sine of one of the acute angles is 15/13. Looking at number 9 and number 11, I know it's going to be the same as the cosine of the other angle. So right now, I should already know this answer. If you don't understand that, then it's fine. I'm going to do it a different way anyway, because I have to do it a different way to find the sine. Alright, so we labeled it. I'm going to just leave the theta here where I had it a second ago. Now, the key here is when they give you an actual ratio, like they did in this instruction piece, they're giving you two side lengths. They're giving you two side lengths right there. Because remember, we know that the sine is equal to the opposite over the hypotenuse. Well, that means the opposite of theta, the opposite, OPP, and this is our hypotenuse. So the opposite of theta is, the arrow up there is 5. And the hypotenuse must be 13 in order for their instruction piece to be true. So you already know two side lengths of the right triangle just from the piece of information they gave you. So now, erase this so it's kind of out of my way. Oh, this is messy. Let me just erase this. Alright, so now we can go ahead and see if we can find the sine of the other angle and the cosine of the other angle as it's asking us for. So I'm going to just put a little pink mark in this angle. This is where we're trying to label the triangle for, because we want to know the sine and cosine of this angle. So I'm going to label that as my opposite side. We know where to find the hypotenuse every time across from the right angle. That leaves this one down here to be the adjacent. And now I can go ahead and answer the sine of the other angle. Remember, that's just how you want to read that. is equal to, well, what's my opposite over hypotenuse? Well, I don't have any side length on my opposite. So you got to actually find it. And you need to think. And think to yourself, if I know 2 side lengths of a right triangle already, how do I find the third one? You don't know any angle measure. You could find it if you really wanted to go that route, but something that should come to mind immediately when you see 2 sides of a right triangle given and not the third is your Pythagorean theorem. That should come to mind. So remember, the key to the Pythagorean theorem is remembering that C has to be the hypotenuse. So whatever is on the hypotenuse, whatever length is there, that's what you're going to put. So we know the 13 is our C. The A and the B could be either of the other 2 sides. There's those 2 you can put in either order because you can add in any order. So I'm just going to put this as x squared because we don't know this this side length, plus 5 squared. So we have x squared plus 25, because 5 times 5 is 25, equals 169, because 13 times 13 is 169. And if we solve by subtracting, we get x squared is equal to 144. And then finally, to get x by itself, you do have to take the square root. Since the squared is on the x, that'll invert the squared, and x is equal to 12. Positive, negative 12? So 12. And so now I know the side length for the opposite. Now I can erase this, because I know it now. The side length is going to equal 12. So now I can go ahead, and I'm going to circle that one just since the other ones are circled. But now I can find the sine of that other angle. So the sine is opposite, which is our 12, over the hypotenuse, which is our 13. 12 over 13. Now the cosine of that other angle, 90 minus the theta, is equal to, remember cosine is adjacent over, so adjacent, which is 5, over the hypotenuse, which is 13. And so that's our answer for the sine and the cosine of that other angle. And remember, it's really key that you understand or read that as the other angle, the other acute angle, because we're not talking about the right angle since we know that degree. Alright, so now for the parts where we solve. Well, we're using trig this entire unit, so when you see this and you're trying to solve for a missing side length or a missing angle, depending on what kind of problem you're doing, then you need to go ahead and set it up with a trig function. So once again, the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So to figure out which one you use, because that's the hardest part for students most of the time, I always suggest to go ahead and label the triangle for the angle that's given, or the angle that's marked. So we have the hypotenuse. We know it's always across from this right angle. Always. So always draw an arrow across, that's your hypotenuse anytime. So now, remember, you want to mark the angle that's given. So the 25 is what's given. So if you draw the line across from the given angle, we have our opposite. And then by default, this has to be adjacent since it's only side left. So now I'm looking at, okay, well, which side do I use? Well, or which sides do I use? Always use the side that you want to know and the side that you do know, because you need to only have one missing piece of information in your equation. So you're using the side you want to know and the side you do know. So notice those sides are the opposite and the hypotenuse. Well, there's only one trig function over here that has opposite and hypotenuse. So that is our sine. So we just realized right there we have to use sine. So if we set it up, the format is always the trig function, the angle measure, which is 25, the angle that you used to mark up the triangle, equal to, well, whatever the function says. This function says it equal to the opposite over hypotenuse. So opposite is f, hypotenuse is 7. So now you do have to solve. This is going to require some algebra skills, like I said before. Solving isn't that difficult with trig because you can always make it a cross multiplying problem by just putting a 1 underneath the side that doesn't have a fraction already. And then if you cross multiply diagonally, 1 times anything is just that thing, so that's just f. 1 times f is f. Now it's equal to the product of this other diagonal. Now remember, it's very key to realize you're not multiplying 7 by 25. You're multiplying 7 times the sine of 25. And it's always smart to put the number in front of the trig function that you're multiplying. Oops, that's a 7. I'm going to do that. But put the 7 in front, because if you put it in the back, it just looks like you're multiplying by 25 by 7. You're not doing that. You're multiplying some decimal, because remember, if you put sine of 25 in the calculator, that's a decimal. You're multiplying some decimal that we didn't figure out yet times 7. So now, f is by itself. Should only be like one move when you're cross multiplying. F is by itself, so, or 1 or 2 I should say. So now you're just going to put all this in the calculator exactly how it looks. Don't do anything strange by put the 7 in the back in the calculator or anything. Just put it 7 times the sine of 25. Make sure your calculator is on degree. If it is not on degree, then your answers are going to be wrong if it's in radians or something like that. So you can always reset your calculator right as soon as you take the test, but make sure your calculator says DEG at the top of the little screen. Alright, so if we put 7 times the sine of 25 in the calculator, I am going to have to use my calculator on my phone, which is terrible, but I'm sitting in a car. This is dedication right here for y'all tonight. But I am getting that f is equal to like 2.958 blah blah blah, so we'll go about 2 points. Oof, if I wrote it all like to the third decimal place, it would be like that, but if you round it to like the nearest whole number or whole number, it would be 3. So if it's multiple choice, for instance, you're going to pick the closest thing, but otherwise just make sure wherever you cut it off, you round it appropriately. Alright, so for the next one, we're going to relabel the triangle, or label this triangle, I shouldn't say relabel, but we're going to label this triangle for the trig functions, or with the trig functions, but using this angle that's given, so the 85. So the 85, drawing across from it, remember is always your opposite, because it's opposite side of the angle that's marked. And then that leaves our leftover 43 as the adjacent. So now, once again, if you're trying to figure out which one to use, remember it's always about what's on the triangle. You have the 43, you have the M, so those are the two sides you're going to use, the hypotenuse and the adjacent. So if I look over here, adjacent and hypotenuse, the only one with an A and an H in it is our cosine. So we're going to set it up using cosine. Let me get rid of all this so I can. And remember, it's the trig function, the angle measure, and then equal to, well, remember cosine was A over H, so the adjacent, which is 43, over the hypotenuse, which is M. So now here, when you cross multiply, we put a 1 under there, and we multiply diagonally. Whichever way you multiply first is fine, but realize here you're doing M times the cosine of 85. Well, M is not a number, so we're going to actually have another step here. So M times the cosine, still write it in front, because that 85 is attached to that cosine, equal to the other diagonal, which is 43. So now notice here that M is not by itself. It's sitting right next to cosine of 85. And what I mean by itself is like, here's your equal sign. You got a left side and you got a right side. M is not by itself on one of the sides, because on this whole left side, you have more than M. So basically, I'm going to do that. What we need to do is get rid of cosine of 85. So if it's multiplying by M, the only thing to use to undo it is to divide. That'll undo it. Remember, you can use inverse functions to get rid of something on one of the sides. But whatever you do to one side, remember you have to do to the other. So we got to do cosine of 85, squeezing it in there. But since it crossed out over here, now I just bring down M, and we have equal to whatever this equals. So you can put that in the calculator, see what you get. And let me see what I get on my lovely phone calculator. Might be slightly off, but we'll see. 493.1. So big number, but that's what we get here, and that is what our M equals. Alright, so now number 16, same thing. Label your hypotenuse. Yes, your angle has a letter in it, but don't worry about that. It's actually easier than a side, but that's still the angle that you're going to label the triangle for. So I'm going to draw the arrow across, that's my opposite, and then by default my adjacent's here. So we have two side lengths. We have this one and we have this one. We don't have the adjacent, so we don't need to use the adjacent. We use the sides we know, or the sides we want. So we want the angle, we have the two sides. So what is that? Well, that's the opposite over hypotenuse. So if you look at your trig functions, opposite and hypotenuse is sine. So we're going to do sine of the angle. Yes, it's a variable, but we're putting it. And then equal to the opposite, which is our 13, over the hypotenuse, which is 40. So now it's like, okay, well, P needs to be on one side by itself, but the sine is next to it. So how do you get rid of the sine? Well, you do the inverse sine of the fraction that you have there, and that will be your answer. Well, how do you get this inverse sine in the calculator? You hit, if you're using a 36x, TI-36x, go ahead and hit the sine button twice, and you'll see it change to the sine inverse, which it has this little -1 looking exponent here. So that lets you know that you're using sine inverse, and then just type in 13 over 40 in the parentheses. Alright, and I'm getting 18.97 degrees for my P. So around 18.97 is our angle measure. So anytime you're finding an angle, make sure you use your inverse function so that you can undo the sine that's being done to the angle. Alright, so now we can look at number 17. So here's the angle we're using. And we have our hypotenuse. Remember, it's always across from your right angle. You have your opposite side that's always across from the angle that you're using. We're using this one. And then adjacent by default is that one. So we are going to use the hypotenuse because it has a 32 on it, and the opposite because it has 17. So opposite and hypotenuse is the sine. So we have the sine of the angle, well, we have an S in the angle, is equal to sine, remember, is opposite, it has to be the opposite on top and the hypotenuse on the bottom. And since it's an angle, we need to get rid of the sine next to it, so we use the sine inverse function of 17 over 32, and that is approximately 32.09 degrees. That's what I'm coming up with. So that's that. Alright, so now for these word problems, once again in geometry, I say this all the time in class, it's the students who draw the pictures do better because you're giving a diagram or a visual display of what's happening in the problem, and you're then able to label the problem. So whenever you have a word problem, definitely in geometry you want to draw what's happening. So we have from 25 feet away from the base of a building. Well, that obviously means we have a building. Does your picture have to be all fancy? No. Could you just draw a line for the building? Yes. So, I mean, just make it basic. The angle, now it says 25 feet away from the base. Well, the base is the bottom, so 25 feet away. So that means we know that this side is 25 feet. It's kind of low there, but it's 25 feet. It says the angle of elevation. Now remember, angle of elevation is it's where it meets the ground. So this angle here is, it says to the top of the building. So that angle measures 38 degrees. And then how tall is the building? So we're obviously looking for this height here. So that's x. So if we realize that that's going to form a right triangle, then we can label our hypotenuse. We can use the angle 38 here to label opposite. And then by default, the 25 down here that I'm squishing down there is the adjacent. So if we want to solve for the height, we want to use the opposite, and we know the adjacent. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So the only one that deals with the opposites and the adjacent is our tangent. So we're going to set the problem up just like before in the other ones. Tangent of the degree, which is 38, is equal to the opposite. Remember, opposite has to be on top in tangent. So that's x over the 25, which is the adjacent. So just as we did before, we just set it up to cross multiply. So 1 times x is just x. If we multiply the other way, remember this is 25 times the tangent of 38. Remember, you want to put the number in front of the tangent or the trig function. And if we do that, notice that the x is already by itself on one side of the equal sign. So right now we're ready to go ahead and put in the right hand side in the calculator. So once we put all that in, we get approximately 19.53 feet. So x, or the height of the building, is about 19.53 feet. Alright. So for the next problem, we have a kite is 35 feet in the air. So have you ever seen a kite or flown a kite? A kite does not fly straight up. That would be weird. The idea of a kite is that oops, hold on, I hit the wrong button here. The idea of a kite is that the wind blows the kite, the wind catches the kite, and it will, if you're holding this little person and they're holding the kite string, it'll fly basically at a diagonal. So when they're saying a kite is 35 feet in the air, well, that's the height of the kite, even though it's not attached to the string right there. That's just how high it is in the sky. So you never measure height diagonally. If you measure height, you're going straight from the bottom of the ground straight up. So to see the height of the kite, you're going there on that vertical. Now, it does say the string, though, forms an angle of 62 degrees with the ground. So let's extend the string out a little bit. The angle it makes with the ground would be here. They're saying that's 62 degrees. And then how long is the string? So in blue here, where this little man was holding it, or woman, the string is our x. So if we set it up using the right triangle trig, notice your right angle would be here. That is your hypotenuse because it's across from the right angle, but the angle we're using is 62 degrees. Across from that, remember, is our opposite, and then adjacent is the third side. So we have something on the opposite side, and we have the x's on the hypotenuse. So opposite and hypotenuse, if we look at our trig functions over here, that is opposite and hypotenuse is sine. So we're going to set it up using sine. Sine of what? Well, sine of the angle you used is equal to opposite on top, so the 35, over the hypotenuse on the bottom, which is x. So now if we cross multiply, 1 times 35 is just 35. It's equal to the other diagonal. Well, that's x times the sine of 62. Remember to put the x in the front, or whatever's here, put it in the front. And now x is not by itself. Remember, x has to be on one side of the equal sign by itself, and it's not on the. It's on the right, but sine of 62 is also on the right. So we're gonna have to get rid of that sine of 62. Remember to do that. You just divide to get rid of the multiplication by sine of 62. That'll cross that out, but we have to do it over here to keep it even, balanced. All right, so now we have x is equal to 35 over sine of 62. I just boxed it to not have to rewrite it over here, but I'll write it anyway. But we can actually punch that in the calculator and see what that equals. And we should get that x is equal to 39.64. So feet. Since we're talking about feet, I think that's our units. Yeah. So x is 39.64 feet, or basically the length of the string would be about 39.64 feet. Alright, so for the next one, number 20, we have Lucy. Her eye level is 4 feet from the ground. So I'm going to draw Lucy here. Here's Lucy. So her eye level, here's her eye. So that eye level right there is, I'm going to put a little curly on the back of her. So from here to here, that is 4 feet. And she stands 10 feet away from the base of a tree. So she is 10 feet away from the base of a tree. And let's see, from her, so 10 feet away from the base of the tree, from her line of sight, she is looking at an angle of elevation. So her line of sight, she's looking at an angle of elevation, so I know that is an angle that is formed with kind of a horizontal line, horizontal line to the top of the tree. So she's looking, kind of made her the size of the tree, but let's see. If I could draw a line that makes somewhat of sense. We'll pretend our tree's a little taller than it is. So, make my tree taller because she wouldn't be the same height as the tree. Just have to go in the words a little bit. Okay, so she's looking at the top of the tree, and it says that her line of sight and angle elevation, so I'm going to drop a line here. The angle is 40 degrees. Now, our right triangle will be formed here and here. So it wants to know how tall is the tree. Well, first of all, if you look at this problem, you got to realize they're saying the angle of elevation, that's where she's looking. So this horizontal distance here can be raised up because it's still the same distance away, 10 feet. Now, we can find this over here, but notice that won't be the full height of the tree. We still have some distance right here that we do know, if you look at it, we know that her eye height is 4 feet. So that can come transfer over here. So now once we find x, you got to realize the attack here. Once we find x, we're able to add that to the 4 feet that we already know, and that'll give us the total length of the tree. So I'm going to explain that approach again. So if we find the missing side here that we need to represent part of the height of the tree, we can add it to the 4 feet they gave us, that is the height of her eyesight. So, to find this, we label our triangle, and you know, if it gets a little messy like mine does, and you understand the concept, you can transfer it somewhere else. So I'm going to transfer it over here. Ooh, didn't mean to flip pages on you. Alright, so this is 40 degrees. We know this is 10 feet, and we're looking for this. So now I can go ahead and label my triangle. We got hypotenuse. We have the angle here, so that's our opposite. And then we have our adjacent. So now, if we go ahead and look at our trig functions. Oops. Hit the page number. Alright, so if we look at our trig functions, we're going to use the x. So we want the opposite and the adjacent, which would be our tangent. So if we set it up, tangent of the angle is equal to, well, remember tangent is opposite over adjacent, so the opposite has to be on the top, adjacent has to be on the bottom, and we can cross multiply. So 1 times x is x, equal to 10 times the tangent of 40. Remember, you want to put the number in the front because you don't want to look like you're just multiplying 40 times 10. And now we can put this in a calculator, and we'll get that x is equal to approximately 8.39 feet. Now remember, that's just your x. If this was a multiple choice question, guarantee this answer is going to be sitting over there as an option, because they want you to feel like you've done so much work, you have your answer. Go back and look and see if you answered the question. How tall is a tree? We didn't answer that yet. We answered just how tall part of the tree is. But at least we know that. Remember, our attack was to find that x, which we know is now 8.39. So now we just need to add to it the 4 feet. And if we add to it the 4 feet, also in the answer choices, you should be seeing 12.39 feet. Oof, running out of space. So in reality, this is your only answer. But like I said, most good multiple choice tests will have an answer that, or a number that you get along the way as an option. And that will be wrong. So make sure you understand your attack make a plan, answer the whole question. Alright, so moving right along on the back side of the sheet. Alright, so number 6 wants the 3 trig ratios, so that's the sine, the cosine, and the tangent for angles A and angle B. Well, I'm only going to do it for one because you could rewatch it and do it for the other if you like, and I can give you the answers for it, but I feel like that'll be redundant to do it twice. So I'll do them all for A. So that means I need to label my triangle using angle A. Well, first remember, label your hypotenuse, and then the side across from the angle you marked is and that's our angle A, that's our opposite. That means by default this must be our adjacent down here. And now I can go ahead and do sine, cosine, and tangent. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So to do the sine, I am going to do the opposite, which is 15, over the hypotenuse, which is 17. If you try, you will notice those do not simplify, or that fraction does not simplify. So now if I undo it, or not undo it, but because I can't, because then it's going to undo my answer, I'll just circle in blue. The cosine, remember, is adjacent over hypotenuse, so our adjacent is 8, and the hypotenuse is 17. So that's the cosine of A. Is that? Okay. And then the tangent of A, I'm going to use, I'll use black. The tangent, remember, is opposite over adjacent, so opposite is 15, adjacent is 8, and that does not simplify either, so those are all the final answers. So those are the answers for those 3. So now I'm going to erase this here so I can put the answers for angle B. So if you want to, you can pause it now, try angle B, and then unpause it, and the answers will pop up. Just like that. So sine of B is 8 over 17, cosine of B is 15 over 17, and tangent of B is 8 over 15. Alright. So now, number 7 says draw triangle CAT. So it says where ATC, angle ATC, is the 90-degree angle. So angle ATC, so I know it's a right triangle. So I'm going to draw my triangle. Doesn't matter how you draw your triangle as long as you label it as they tell you to. So the first thing is make sure you notice ATC is the 90-degree angle. So that's telling you right there, remember your vertex is always in the middle, that T has to be on the 90-degree angle mark. And then it says CA is 53. So now those are my other 2 letters I have to put somewhere. No matter where you put them, C to A, or A to C, no matter which direction you put it or look at it in, this will be your 53. And CT will be 28. So C to T is 28. So now it says, what is the length of AT? So if you have 2 sides of a right triangle, remember you use the Pythagorean theorem to solve for the third. Whenever you have 2 sides, Pythagorean theorem to solve the third. Remember that the C has to be the hypotenuse. No matter what, that has to be the 53. And then the missing side here, I'm just going to leave it as A squared. You can make it X if you want. And then the 28 squared. Remember, A and B, those are kind of interchangeable. You could have did 28 squared plus B squared if you really felt like it. So those 2, they're both the legs. Doesn't matter which order they go in because you're adding. So A squared plus 28 squared, we have 784 is equal to 53 squared. Something tells me I'm not going to have room to write this number. 2,809. Squeeze it in there. So now, to get A by itself on one side of the equal sign, we subtract 784, and we get that A squared is equal to 2,025. So remember to get rid of the squared that's on the A, because you need A all the way by itself. You take the square root, because those are inverses, and the square root of 2025 is 45. So A equals 45, and that is what they wanted us to find, which is the length now of AT. It's no longer missing, we know it. Draw a line because it's all merging together. So now we know the length is equal to 45. So with that, we can now answer these other questions about the sine of C. So sine of C, that means I need to label it for C. So this is my angle I'm going to label it for. So of course we have our hypotenuse, never changes. Opposite is across, so I'm going to squeeze that in there, and then adjacent is down here. So sine, remember, is opposite over adjacent, opposite over hypotenuse. So opposite, which is 45, over hypotenuse, which is 53. And if you try that in the calculator, it will not simplify. So notice you have to relabel the triangle for the tangent. So I would actually have to redraw it since I'm using this app. And so instead I'm just going to use, I'm sorry, I had to check the notification, but I'm going to use blue. So the tangent of A, well, here's A. Remember, you got to relabel the triangle except the hypotenuse. Now this is my opposite, so we're going to get rid of that. We're going to put opposite. And then hypotenuse never changes, so that's still hypotenuse. Let me not circle it. Why'd I scribble it out? I'll just do it anyway. Okay, hypotenuse. And then that makes this side the adjacent. Sorry, it's so messy. It's just hard to erase, and then I have to redraw. It's too much time. So now we have the tangent. Remember, tangent is opposite over adjacent. So opposite labeled here in all this scribble scrabble is 28. And then the adjacent, if you look, is 45. Hopefully you are using eraser or have more space. Or scratch sheet, that's a good idea. So 28 over 45, if you try to simplify it, it doesn't simplify, so you are done at that point. Alright, so I'm going to have to erase some of this other stuff to fit in number 8. So let me just erase this picture. Write that smaller. That'll be good. So 28 over 45. Alright, so now number 8, it kind of gives you a lot of information. You just got to realize it gave you a lot of information. First of all, it tells us the same type of thing. It just tells us side lengths in this format. So I'm going to draw my triangle. And we have a right triangle. It says B is the 90-degree angle. Remember, right triangle is 90 degrees. So this angle here means it's 90 degrees. So that's our angle B. That means A and C, have to be the other two angles. And like I say, you could have easily decided to put A here and C here, because no matter what, it's still the same length. Either way, it's still the length of AC or CA, which is the same. Alright, so we got C, we have A, and it tells us the sine of A is 12 over 20. So basically right there is telling you that if you label the triangle for angle A, the opposite over the hypotenuse, since it's talking about sine, will be 12. The opposite will be 12. The hypotenuse will be 20. Well, the hypotenuse never changes, so there's my hypotenuse. I already know that's 20, since they said the sine of A is 20 or 12 over 20. Now I just got to label the triangle for A. So we got hypotenuse, we know that's 20. We have across from the angle, that's our opposite. And notice, the opposite, the information is telling us that the opposite is 12, length 12. And then we have our adjacent sides here, but we don't have the side length for it. So it's telling us right here in this question to find the length of AB. Well, we need to find the adjacent. So I'm going to label that as our x. So one thing we can use is the Pythagorean theorem once again, just like we did in the previous problem. So we have a squared plus b squared equals c squared. Remember, c has to be the hypotenuse, so our hypotenuse is 20. So 20 has to go for c. A and b, that's any order, so x squared plus 12 squared. And if we square the 12 times 12 is 144, and 20 times 20 is 400. So just like before, x has to be by itself. So if you subtract the 144 from both sides, you get x is equal to, or x squared is equal to 256. So remember, to undo the squared that's on the x, you have to take the square root. So x is equal to 16. So that, remember, x is just what represents our adjacent side. So now we know the side length is 16. So that is number 8a. And now, just like the problem before, we can go ahead and find the tangent, cosine, sine of either of the acute angles. We have it already labeled for a, which is good. So now remember, tangent is opposite over adjacent. So I need the opposite, which is 12, over the adjacent, which is 16. That does simplify. So remember to simplify if it does to 3/4. So now the cosine, remember cosine is adjacent over hypotenuse. So our adjacent we have here is 16, hypotenuse is 20, and that also simplifies, which I'm just going to bring it up here because I don't have space, 4/5. Now this arrow is irrelevant, but yeah, 4/5. So that's our final answer for that one. Alright, so moving on to number 9, we are having to solve, just like we did on the front, set it up like a, with the trig functions. You have one piece of information and you have two known pieces of information, so figure out which trig function to use and set it up. So first, theta is here, so, I should probably change it to pen. Alright, so theta is here, so we're missing this angle. And it says solve for the missing side or angle using the trig functions. So we're missing the angle. We want that angle, so we're going to label the triangle for that angle. A lot of times students get confused when the triangle is laying like this because just the order, or you're used to the bottom being the base of the triangle. But it's always about find that right angle because it's kind of pointing to the hypotenuse. So this triangle is laying on its hypotenuse. Now, the angle we're using, once again, is the theta, so a drawing across from the theta is your opposite, just as usual, and then you have your adjacent. So nothing different, it's just laying different. So now, if you look at it, we have side lengths on the adjacent and on the opposite. So your trig function, I'm just going to rewrite the trig functions up here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and we already have tangent there. Notice the only one that deals with opposite and adjacent is our tangent. So we're going to set it up with tangent, and I just don't know if I have space, but we'll see. Tangent, remember it's always of the angle measure, which we don't know is theta, and it's opposite on top for tangent, so it's 4/13. So remember, if you're having to solve and the only thing next to your unknown information is a trig function, you have to undo the trig function by using the inverse trig function. Remember to tap your calculator tan button twice, and you're going to put the inverse tangent of 4/13 in your calculator, and you should get approximately 17.1 degree. So that was supposed to be approximately signs, but anyways, 17.1 degrees is the measure of theta. So whenever you're using or finding an angle measure, you always use, so for angle measures, use inverse. That's supposed to be an I, which it came out really bad. So we'll just do that kind of I. Inverse trig functions. Anytime it's an angle. Alright, so letter B. Need some more room. So I'll just do it to the right here. So once again, set it up. So we have our angle. We have our 90-degree angle here, so that is our hypotenuse here. We're using the 32, so that is our opposite across from the 32. That means this is our adjacent. So now if I'm trying to decide which one to use, I want to use the ones that we have something on. So we have x and 13. So that's opposite and adjacent. So once again, we're using tangent because tangent's the one that deals with opposite adjacent. So tan of what? Tan of the angle, 32. opposite is x, adjacent is 13. So as we did earlier, we make it a cross multiplying problem. And so if we multiply diagonally, we get x is equal to the other diagonal. Remember to put the number that you're multiplying by in front of the trig function. And then you go ahead and see what that equals in the calculator. That equals, because x is by itself, that's why I'm putting in whenever x is by itself on one side of the equal sign, remember you could just now put all that in the calculator. So 13 times the tan of 32 looks like it is approximately 8 point, it's a terrible 8, but it's an 8.1. So it's a side length, so it's not degrees. So it's just 8.1. We don't have units or anything, so we'll leave it as 8.1. Alright, so letter C. We have a hypotenuse here, because remember it's across from your 90-degree angle, your right angle. We have an angle here. We're using the angle given. Across from the angle is your opposite side. And then we have our adjacent side. And now we're going to see what trig function we're going to use. So let's see. We got the hypotenuse is given, and we need our x's on your adjacent. So the one that deals with adjacent and hypotenuse, remember look over to the left, is your adjacent hypotenuse is our cosine. So we have cosine of our angle measure is equal to, remember it's important the order, so if you look at cosine, it's adjacent on top over your hypotenuse, which is 11. So now when we cross multiply, well, let's set it up to cross multiply. We got to put a 1 there. So we have 1 times x, which is just x, equal to, and then 11 times the cosine of 60 degrees. X is already by itself on the left side of the equal sign, so now we can just put in 11 times the cosine of 60 in the calculator. That gives us about 5.5. So final answer is 5.5. Next. Alright, last bit here, last bit. So D, we have same situation, we have an angle measure given. Let's go ahead and label the hypotenuse. We have our angle, which is 50.1 degrees, so across from that is our opposite side. And then we have our adjacent is the third one always, or the one left over. Alright, so now if we look at what's labeled here, we have the opposite side is our x, the 5 is given on the adjacent, so we're going to use those two sides. Opposite and adjacent, that's our tangent. So tangent of the angle, 50.1, is equal to opposite over adjacent. So set it up to cross multiply, just like the previous problem. So we have x is equal to 5 times the tan of 50.1, and all that tells us that x is equal to 6, approximately 6. So these should be squiggly equal signs because we are rounding, so it's about 6. Alright, next problem. Here is our hypotenuse. Here's our angle measure. That's not given, but it's theta. We will find it. So we have our opposite side because it's across. Then the leftover one's the adjacent. And now we're going to use the one that has a 7.7 on it and the one that has a 14 on it. We don't need to use the hypotenuse because nothing's on it. And we are going to use, since it's A and O, or O and A, that's tangent. So the tangent of the angle measure, which is theta, is opposite over adjacent. And remember, you're looking for an angle measure. Anytime you have the angle measure, you need to get it by itself. The only thing next to it is tangent. So you have to undo tangent by using tangent inverse. So we just put it in, because remember, finding the angle is easiest. You just really hit the button in the calculator twice if you're using a 36X Pro, or whichever calculator you're using. Find the tangent inverse button. It must have the little -1 there when you're finding angle measures. And that is approximately 28.8 degrees. So that is what our theta equals, or is approximately. So now letter F, we have our hypotenuse, have our angle, so across from the angle is our opposite side, have our adjacent, we are using the x side because we need x, and we have the 10.8, so we're using h and o, so that is sine, let's see, I really don't have room for this one, sine of the angle, which is 57, is equal to opposite, which is 10.8, divided by the hypotenuse, which is x. Now if we set this up to cross multiply, 1 times 10.8, let me erase this adjacent since we're not using it. Alright, so 1 times 10.8 is 10.8, and equal to x times the sine, sine of 57. Alright, now I'm squishing it in there, but I don't have much room. So x is not by itself. It's on the side of the equal sign with the sign of 57. So to get rid of the sign of 57, remember you divide. Do that on both sides. And cross that out. So we have now x is equal to all that. Got to figure that out in the calculator, put it in as in fraction form, and you will get that x is approximately 12.9. So x is about 12.9. Alright, so number 10, we have an 8-foot ladder is leaning against a wall. Well, obviously we know a wall is vertical. When a ladder leans, if you ever imagined, saw a ladder leaning, a ladder isn't laying straight up on a wall. It will fall down. So a ladder, what it means by leaning, let's say someone's using the ladder, they're going to lean the ladder against the wall that way. So there's our ladder. So it's kind of resting on the wall to where someone can use it. I'm just emphasizing that because people be drawing ladders like when it says leaning against the wall, just imagining no space between the wall and the ladder. But anyways, an 8-foot ladder, so that's how long the ladder is. So basically the ladder itself is 8 feet long. And the base is 5 feet from the base of the wall. So the bottom, when you think of base, think of bottom. That bottom and the bottom of the wall, it's telling you that that is 5 feet. And it wants to know what angle, so we are finding an angle, does the ladder make with the ground? Well, the ladder meets the ground right here. So we want to know that angle. Since it's an angle, I'm going to use x. But I also am going to make this look not so sloppy. I don't know why I said sloppy like that, but there we go. Alright, so we're going to call this angle right here theta, since we don't know the angle. So we want to find that angle. So we're using that angle to label the triangle. Hopefully you see the right angle would be here. Forms a right angle with the ground. So this is our hypotenuse. We have our opposite from theta is over here, and our adjacent is down here. So we're using the adjacent because we have that length. We're using the hypotenuse because we have that length. So adjacent and hypotenuse, remember, is cosine. So cosine of the angle is equal to adjacent over hypotenuse. So now, remember, you're finding an angle. We need to get rid of this cosine. You don't divide, you invert the trig function. So the inverse cosine of 5/8 is equal to, remember, finding angles are easier. You just use the inverse functions. Let me see, did I put the right? Oh yeah, okay. So I just had to make sure I put it in right. We have 51.3 degrees. 51.3 degrees is our roundabout angle measure for theta. Alright, number 11, surveyor standing 25 feet from the building, or from a building. So here's our building. I'll make it real skinny. He is standing 25 feet away from our building. So here he is, or she. Did it give us a gender yet? Yep, his, not yet, but it will. He's looking at the top of the building. So an angle of elevation of 65 degrees. So if he's looking, that angle that he's making is coming off of his eye. So make that a little better. So this right here the angle, it always makes it with a horizontal path. Remember, that horizontal line could be shifted up. It's still the same length no matter what. So that angle right there is 65 degrees. So technically, if you know about angle measures, my picture is very poor, but it'll work. So the most we can find is this length here, or one of the sides of the triangle, but the triangle is raised up in the air. It gives us that his eye height, so basically from here to here, or if you think of it, that could be shifted over here. So from here to here, we know that height is 6 feet. We want to know how tall the building is. So this is just like the problem on the other side. So we need to know this little piece of the building, because we know this piece down here is 6 feet. We need to figure out how much this is here. So we can go ahead and find x and then add it to the 6 feet that we already know for the building. So I'm going to redraw my triangle so it's not so smashed looking. Oof, that's just ugly. Let's undo that real quick. Guess I'm trying to rush a little bit. Alright, so that's 65 degrees. And we know this is our right angle. We know this is our x. I'm just redrawing this triangle over here so it's not so smashed. And we know this is 25. So if we label it for the 65 degree angle, of course the hypotenuse is here, but your opposite is here, your adjacent is here. So if we set it up, we're going to use the side we want to know, the side we do know. So opposite and adjacent, we're going to use tangent. So I'm right over here, tangent of our angle is 65, equal to, opposite has to be on top, so x over adjacent, which is 25. If we set it up to cross multiply, 1 times x is just x. 25 times the tangent of 65, so 25 times tan, 65 degrees. Notice x is already on the left side of the equal sign by itself, so I could just punch all this in the calculator. And for number 11, you'll get 53.6. Once again, this question on a test in EOC, something like that, is going to get lots of you because 53.6 will be sitting over there in the options. But you just found x. So x is equal to 53.6, but that's not the total height of the building until you add it to the 6 feet. So if you add those together now to get the total height of the building, you have that the building is 59.6 feet. So again, don't let the problem get you. Make sure you actually looked at it and made a plan and figured out, do I need to add anything to it? Do I need to go back and plug it in? What needs to happen? Alright, so that's our final answer for that one. Alright, so last one. So we have a kite is being flown. So once again, a kite does not fly straight up in the air. That does not happen. A kite flies with the wind, so therefore it flies diagonally, and it's being flown using 150 yards of string. So 150 yards of string. And it says the kite has an angle of elevation. Remember, the angle of elevation is always formed with a horizontal line. Remember, if it said depression, let me just do this quick sketch real quick. So let's say we have this going on. So this, the angle formed with the line, is your angle of elevation. And then the angle formed with a horizontal line on this side would be your angle of depression. So just remember that. And if you think about, since these are both vertical, these are alternate interior angles, so they'll be the same measure. Alright, so we have 150 yards as our string. Going back to the problem over here on the left. The kite has an elevation, oh, I didn't put my 65 degrees. Hold on, 65 degrees with the ground. That's where we were. And then we want to know how high is the kite in the air. So basically we want to know the height. So this is our x. So hopefully you see the right triangle has been formed. And now we can use our trig. So we have hypotenuse is here. Our opposite is here. And then we have our adjacent. So we're using the opposite because that's our x. We're using the hypotenuse because we know it. So we have opposite, hypotenuse, that is sine. So sine of 65 degrees equals opposite, which is x, over hypotenuse, which is 150. And we're going to cross multiply. So we have x is equal to 150. Remember, put the number in first, or first that you're multiplying by the trig function, times the sine of 65. Oops, that's a parentheses, that's a parenthesis. Alright, and then that is approximately, well, let me mention that really quick. Remember, x is already by itself in one side of the equal sign, so you can go ahead and punch all this in the calculator, and you should get that x, or the height of the kite, is, make sure I have it right here. Oh, I'm moving too fast. Dun, 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 dun. It is approximately 135.9. Remember, it's not an angle, it's a side, or the side of a right triangle, but it's the height of the kite. And the measurements are not in feet, they are in yards. So that's how high the kite is in the sky. Alright, now we didn't have to add it back to any surveyor's eye height or anything like that, so that's our final answer on that. Alright, study up. I hope you guys get it. If not, watch it over and over until you do. That's what being studious is. You study till you get it. But be ready. Good luck. Adios.